Again, I'm going to give you an equation and we're going to graph this linear relationship. So we have y equals 1/4 x plus 2. When we look at a linear equation, the first thing that we always want to identify, at least the way that I do it, Regina, is I always want to identify the y-intercept first. Our y-intercept is 2. And then after that, I want to identify our rate of change or slope, which is 1/4. And remember, our rate of change or slope, we know that that means change in y over the change in x. Now we're going to graph this linear equation. Everyone's body should be facing the front, please. Thank you. We're going to graph this. Now first we're going to graph, or we're going to put the y-intercept onto our graph. What's the y-intercept here? 2. Is it a negative 2 or a positive 2?
Positive.
It's a positive 2. You have to look for it because sometimes if this was 1/4 x minus 2, that would mean that our y-intercept was what?
Negative.
Negative, right? So here, our y-intercept is a positive 2. I'm going to put a point there. That point, yes, it's 2. But if we're seeing it as an ordered pair, we would write it like this. 0, 2. And then from there, we're going to use the rate of change to see how the line is going to work here on this graph. Thanks for paying attention. So our change, what's our change in y here for this rate of change?
1/4.
Well, what's the change in y?
2. The change of y
Is 1, right? The y is changing by 1. If we look this rate of change, the rate of change means change in y is changing by 1, x is changing by 4. So we're going to go up 1, and then we'll go up 1. How much is the x changing by?
4.
4, so we're going to go over 4. 1, 2, 3, 4. I'm going to put a point there. And then again, we're going to go up 1 over 4. I'll put a point there. And then we'll continue on. We'll go up 1, and then I'm off the screen by now. So again, the first thing that we did was we identified our y-intercept, which was 2. Our rate of change was 1 over 4. So we go up 1 because the y is changing by 1. We go over 4 because the x is changing by 4. Up 1 over 4. Up 1 over 4.
So we keep going up 1 over 4 because of the 1/4?
Yes, right? Now, so I've showed you what a rate of change as a fraction looks like. I'm going to show you if you had a whole number rate of change, what this would look like. So let's go back. I'm going to give you a new equation, and then I'm going to let you get started on today's activity. So let's say we were doing y equals 2x plus 1. What's the first thing that I asked you to identify when you're looking at a linear equation? Positive or negative what?
Rate of change.
No, it doesn't matter, honestly, if you identify the rate of change or y-intercept first. But personally, I think for you guys, it's easier to identify the y-intercept first. So what's the y-intercept here? 1. Is it a positive or negative?
Positive.
It's a positive, so we're going to put it where positive 1 is on the y-axis. That's where our line is going to cross. Shh. Let's actually make this a negative 2. I want to make the rate of change a negative 2 so you can see what the negative slope looks like. Now, we have a whole number here. The last one that we looked at was a fraction rate of change. And so it was easy to see what the change in y over the change in x is. But here we have a fraction, we have a whole number rate of change. Before we can use this on our graph, what do we need to do to this whole number? We need it to be a fraction or ratio, right? So what can we do to this whole number to make it a fraction or ratio? We can what? We can put a 1 underneath it, right? How do you make any whole number into a fraction? You put a 1 underneath it. Stop being immature, guys, please. Thank you. No, it's okay. Shh. You put a 1 underneath it. So I'm going to put a 1 underneath this. So this is the same as saying y equals negative 2 over 1 x plus 1. You're not going to see it in problems like that because the problems are going to expect for you to understand if there's a whole number, you know that means the change in y over the change in x, and you're going to have to put a 1 underneath it, right? Now from here, we started out at my y-intercept. What's my change in y here? Negative 2. So am I going up, down, left, or right?
Down.
We're going to go down. So we'll go down how many?
2.
We'll go down by 2. And then our x changed by what?
1.
By 1, positive 1. So we'll go over 1. I'll put a point there. And then from there, it's just a pattern. Down 2, over 1. Put a point there. Again, down 2, over 1. Put a point there. And then from that point, we could draw a line. Let's see if I can draw a good line here. The negative slopes are difficult for me to draw a good line through. Right? That would be the line. That would show our linear equation or the relationship. Yes, ma'am.
If it's negative, it goes down.
Yes, if we have, yes, and that's exactly why I showed you using a negative rate of change. Because if you notice the last ones, if it was a positive rate of change, they go up and to the right. If it's a negative rate of change, they go down and to the right. Everybody see that? All right. So again, what I'm going to do today is I'm going to give you a list of equations and some graphing paper, and you're going to take the equations and you're going to have to graph them. Is there any questions?
We have a graph already done, or will we have to make the graph?
No, I'm going to give you some pre-made graphs already because it takes too much work for you to actually have to make the graphs. All right, get back to your seats.